Hi folks, Dr. Creek here. In this video we're going to go over correlations and regression using Excel. Excel is a really nice tool for this and pretty powerful, honestly, considering it's either free or very cheap compared to some other statistics programs. And so I've got this worksheet pulled up here. This is what we're going to go through and kind of work through as an example. In this example, we're working with a bike rental company. Okay, and so what might a bike rental company care about, right? They might care about how many bikes they're able to rent because that's how they make their money. And so we've got a bunch of data. I'll be using an Excel data set here. And specifically, as the prompt says here, we've got 2 years of past data weather, and we've got some variables involved. So the variables we can use to predict bike rentals in this example is the temperature, how warm or cold is it outside. We've got the humidity level, and we've got some wind speed. So basically, we're trying to hypothesize here, does weather impact bike sales? Probably we would think it would, but let's go ahead and see. My assumption here, before we dig into the actual questions, is that you've already gone through my 2 PowerPoints on this, so one on multicollinearity and then the other on regression analysis. So assuming you've done that, let's move forward here. Question 1 says, create a correlation matrix for rentals, temperature, humidity level, and wind speed. So we've got 4 variables here, and it's asking us to create a correlation matrix. So there's no real answer for this question, it's just a to-do. So let's go do it. Here is my data set. I've posted this data set on our course space. If you want to go, try to do this yourself, you're welcome to do that. It's in a folder. I think it's called Files for Regression Video, something like that. Okay, so the first thing you need to do in order to make this correlation matrix is you need the data analysis tool pack. And in my slides, okay, I've given you instructions on how to get that data analysis option. If you're on a Mac, this might work a little bit different, but if you're on PC, this should work. I've already got it installed, so I don't need to do that on my machine. To do the correlations, you click on Data, and all the way in the bottom right corner, you'll see this data analysis option. It's an add-in that you need to install, but once you have it, you'll be set for all the assignments we're doing in this class. So there's a couple of things we need from here. One is regression, but right now, of course, it's asking for a correlation. So we're going to select correlation and hit OK. Correlations are really easy to do with this data analysis tool pack. And I say that because we can literally just select all of our data at once. Okay, so it's asking for an input range. In other words, what do you want Excel to correlate? And we can just select all the 4 variables that matter to us. Temperature, humidity, wind speed, and rentals. And we're going to select both the headers and all the data underneath. And if you recall, our prompt told us that we have 2 years worth of data here. And so that's why we've got a little over 700 data points, is because it's the days from 2 years worth of data. Okay, so I've selected all of that, and you got to make sure that you include labels in first row if you select the actual words in row number 1 there, which I've done. Hit OK, it'll put it in a new worksheet ply down here, which is just fine. And here is my correlation matrix. And we might even name that correlations so we can reference it more easily. And pretty small table, but it gives us some meaningful data here. So let's go see what to do next. So we've created this correlation matrix now, and now we can go ahead and interpret some stuff. So interpret the correlation between rentals and wind speed. Okay, if we go to our correlation matrix, rentals and wind speed. Okay, here's wind speed, here's rentals, and so the number it's looking for in this case is this negative 0.23. Let's round it to negative 0.23. Okay, what does that tell us? Well, here too you can refer to the slides. Okay, specifically what we're after here is this slide, interpreting correlations, and anything below an absolute value of 0.6 should be considered no relationship. Okay, so that negative 0.23 that we saw here, we could just say there's no relationship. Stated differently, rentals and wind speed aren't correlated. All right, let's go on to number 3. So interpret the correlation between rentals and temperature. So we can do that as well. Rentals and temperature. Now we're looking at this guy here. And here we see a bigger number. If we round that, let's say it's a positive 0.63. And here we have made that threshold. Okay, so it's positive. And because it's positive, we need to be able to say two things. When we're talking about correlations, we care about the strength of the relationship and the direction of the relationship. So in this case, the strength is moderate and the direction is positive. So our interpretation here would be there is a moderate positive relationship between rentals and temperature. Notice with correlations, we're not saying one is causing the other. It might be, but we don't know that yet. It's just a correlationship, which is why we just say there's some kind of relationship. We don't know if one's causing the other. There's just a correlation here. And again, for number 2, we could just put no meaningful relationship, no correlation. All right, let's move on. So run a regression analysis using rentals as the dependent variable. Okay, that's what we're trying to predict. If we look at our regression equation, which is y equals a plus bx, the dependent variable in that equation is y. These others, temperature, humidity, and wind speed, those would be our 3 independent variables, or in that equation, those would be our 3 x variables. Okay, I've kind of given you this part. All variance inflation factors are below 10, so it's safe to proceed with the analysis. I'm gonna spend some time here on number 4. I want to show you in Excel how to do this with the VIFs. It's a bit tedious. I'm never gonna make you memorize this, like for an exam or even a homework or something. I've given this to you. It's in your notes. Okay, right here, how to calculate VIF. I put this slide in yellow. It's just a way, like, for me to remember. Like, don't make folks memorize this. It'd be pretty crazy to do. This is like the one area where Excel could be better, I think. And the statistical programs that cost like, $2,000, they'll do this for you. We can do it in Excel, but it's a little more manual. You have to know this formula here, which is a bit complex. Nonetheless, let's go in here and try to do this. Okay, so in order to do this, we need to now run a regression analysis, and we can use the same data set as before. I'm going to go back to data analysis, and this time regression. And we're just going to run a regression analysis using, right, here's the y range. So y is our dependent variable, or rentals. So for y, we're going to select all of the data underneath rentals. And then we've got 3 independent variables, or x variables. Okay, and so for my X range, I can select all three independent variables at once here. Temperature, humidity, and wind speed. And again, just go down to the bottom of this. And now we have everything we need for our regression equation here. Okay, again, you want to check this labels box, and that way it'll show you, which variable's which. I'll show you what I mean here in just a minute. You can hit OK. And here is our output. Maybe we name this one regression. Okay, and you see right here it says temperature, humidity, and wind speed. The reason it says that and not just something arbitrary is because I selected labels. Okay, if I hadn't selected labels, this would just say like X1, X2, X3. You wouldn't know what it's talking about. So it is nice to include those labels. That's a bit of a moot point, but nonetheless, that's why we do that. All right, if we go back to our notes, talking about VIF, we need all kinds of data in order to solve this equation. Fortunately, most of these are given to us by the regression analysis, except for standard deviation. Okay, so let's go label where these are, the easy ones. So individual standard error of each predictor. Okay, standard error right here. Let's go ahead and highlight those. All right, it's the first one, sample size -1. Sample size is always represented by an n in statistics. Well, most of the time, I guess I should say. n-1 is actually given to us. Notice the number of observations is right here, 731. n-1 is given to us in this ANOVA table right here. So it's just the sample size of 731 minus 1. So 730 is right there. Okay, the last thing we need, other than standard deviation, is the overall standard error. And that's given to us right here. And now we need standard deviation, okay? And standard deviation isn't given to us in this summary output. So the way I like to do this is I just create another column here. We don't need a standard deviation for the intercept. Okay, we only need standard deviations for our independent variables, which is temp, humidity, and wind speed, the weather factors here. Once we have that, then we can figure out our VIFs. Okay, Excel does have a built-in formula for standard deviation. And so there's many different ways you could do this. I like to use standard deviation of the sample, so stdev.s. And this will be my standard deviation for temperature. So I'm going to click on that. There we go. And then I need to give it some data. So standard deviation for temperature, I go back to my data set and I select all of my temperature data. Okay, 22.88. Do the same thing for humidity. Notice here I don't want to include the word humidity, it's just the numbers. It'll give you an error if you include the word here. Okay. Now if you look up at the actual formula, we can see that it's C2 to C732. This is D2 to D732. And so I know this one's going to be E. So I could just go copy it again if I wanted to, or I could just change these C's to E's, and that'll give me the same standard deviation. All right, so that's the last piece of this crazy VIF formula here. And so let's try to actually solve this now. All right, so in the numerator we need individual standard error squared times n-1 times standard deviation squared. Let's start with that. individual standard error. We might need some parentheses here. We're going to square that, multiplied by n minus 1, multiplied by the standard deviation, also squared. Okay, so that's our numerator, pretty big number there. But then we have to divide that, right, by the overall standard error. So more parentheses, I'm going to divide all of that by my overall standard error, which also needs to be squared. Okay, and you see when I do that, I get this nice little number. And I say nice little because if you go back to your slides here, you'll read somewhere that we're looking for 10, right? 10 or above equals high multicollinearity, cause for concern. Anything between 1 and 5, though, is pretty good, right? The closest to 1 we can get here, the better. It means these two variables are not collinear. So we're really happy with this number of 1.03. And then we would need to redo this formula here and here as well. I'm gonna actually skip that just to save some time. This is a long enough video as it is. There's a way you can do this a little quicker. So some of these numbers need to move and some don't, so I'm going to lock in the ones that don't, essentially, by adding some dollar signs to my formula. But you don't need to do this. You can if you want. But what that does is it allows me to just drag down my formula here. Saves a bunch of time. Okay, and so here's my 3 VIFs. Okay, VIFs in orange there. 1.03, 1.04, 1.08, really, really small numbers, close to 1. And so all of that that I just did is to show you why I was able to say this. All VIF values are below 10, so it's safe to proceed with the analysis. Okay, so finally we're done with number 4. Let's move on to number 5. How many days are in the sample? Oh, thank goodness, an easy one. So stated differently, what's the sample size? We already talked about this. It's in our regression. This number right here, number of observations, the same as sample size. So the answer is 731. Okay, so stated differently, we could say that sample size is 731 would be fine, or we could say there are 371 days observed in this sample. Either one's fine, full credit for both. All right, interpret R squared. This is given to us in the regression output. Okay, R squared is here. And 0.46, otherwise known as 46%, right? And your notes tell you exactly how I want this to be interpreted, but I'll try to write that here as well. Again, 0.46, same as 46%. And so what we're going to say is 46% of the variance in bike rentals. Okay, so it's always variance of our dependent variable. So in this case, 46% of the variance in bike rentals can be explained by our 3 independent variables, which are temperature, humidity, and wind speed. Okay, in other words, we're saying we can predict bike rentals only knowing the weather with 46% accuracy. Okay, is basically what that means. Better to write it like this, though. All right, number 7. Which independent variables are significant predictors of rentals and why? Okay, so now I think we're into that second spreadsheet, Intro to Regression Analysis. P-values. Okay, so this is what we're looking for when we're talking p-values. Anything less than 0.05 is statistically significant. Okay, and so let's go look at our regression analysis again. We've got our 3 independent variables, and the question is asking us which of these 3 are statistically significant. Okay, so these are the numbers that we're looking for here. Don't be fooled by the 4.1, 2.8, 2.47. I've seen this go wrong a bunch, but notice this is scientific notation. E to the minus 86th, E to the minus 15th, E to the minus 11. Okay, so what this last one means is the p-value for that, it's a 0.0, and there's 11 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then it's 2, 4, 7, 5, 4, whatever. So this is an extremely small number, which means it's very, very statistically significant. Okay, so all of these are very statistically significant, well under that threshold of 0.05. And so we could say all 3 independent variables are statistically significant with p-values less than 0.05. Okay, that'd be a fine thing to write. Moving on. Okay, another pretty quick one here. Fill in the words with up or down. On average, rental volume goes up when temperature goes which direction? The way that we know this, and it's also looking for humidity, but the way that we know this is the sign before our coefficients. Okay, so here's our coefficients. Our coefficient for temperature is 53, but it's a positive 53. So what that positive sign, right, they don't actually write it in. They write it in for the negatives, right, negative 31, negative 71. What that positive here for temperature means is that on average, as the temperature increases, bike rentals also increases. The opposite is true for humidity and wind speed. Okay, for humidity, when humidity goes up, bike rentals goes down, right? People don't want to sweat maybe. And same for wind speed. As the wind speed gets to be like something crazy, and it's 50-mile-an-hour winds, less people are going to rent bikes, right? They don't want to ride bikes when it's 50-degree wind outside, is what this would tell us. And so with that information, we can go answer this. So rental volume goes up when temperature goes up because it had a positive, and humidity had a negative sign, so rental volume goes up when humidity goes down. All right, we're getting there. Number 9, tomorrow the weather is supposed to be as follows. Temperature is 71 degrees, humidity 35, wind speed of 18. How many bikes can we expect this company might rent tomorrow? Okay, and this is where, this is why we did everything before this, right? This is the point of regression and how powerful it can be for forecasting. All right, the way that we do that is to literally solve the regression equation y equals bx. All right, and so let's do that here. Okay, we've got our data, and we need again these coefficients here. All right, and remember our regression equation, just going to write that in here, y equals a plus bx. Okay, in this case we have 3 independent variables, so we have 3 x's. So this is the equation that we're going to try to solve here. Okay, y equals a plus bx plus bx plus bx. So we're solving for y, so what we need is everything after this equal sign here. So a is always the intercept, and so let's select that, right, our intercept coefficient. We're going to now add in b times x. Okay, and so what that means is we know that tomorrow the temperature is supposed to be 71 degrees. Okay, so we're going to take that 71 and we're going to multiply it by our temperature coefficient. Okay, now we're going to move to humidity. Same idea. What's the humidity supposed to be tomorrow? It's supposed to be 35. So 35 multiplied by our humidity coefficient. And then lastly, we need to worry about wind speed. Our wind speed tomorrow is expected to be 18 degrees. So we put in 18, multiply that by our wind speed coefficient. And when we solve this equation, it's going to give us our estimate for how many bike rentals we think this company might get tomorrow. Okay, so we can round that and we'll say 5,471. Okay, and you know, so that's our answer. I guess let me write that in first. Expected rentals tomorrow is 5,471, I think is what we determined. Yeah. And so you can change these numbers and see just how powerful this equation is. So like the temperature, right? 71, that's a pretty comfortable temperature. What if it were like 5? Right? You see that now our estimate goes way down, right? Like by a third. Now it's only 1972. And what if it was 105, right? People don't really like biking there either, maybe. 72, 73, that's probably a bit of a high number. We'll get to why that is in just a second. There's a better way to do this equation here, which is actually what number 11 is about. Okay, 56, did that change? Oh yeah, because this wasn't the right number. 71, okay. 54, 71. All right, let's see what we got left here. Number 10, create a scatter plot graph that shows how temperature relates to bike sales. What might this graph suggest? Okay. So what that's saying is go back to the data and create a scatter plot graph of all of these numbers, basically. The temperature numbers most specifically. So temperature and bike rentals is what we care about. All right, so I want to keep all my data, so I'm just going to copy this data so that I have another set, because I'm just going to delete humidity and wind speed. For this question, we don't care about those two. We want a scatter plot graph with temperature and rentals. And so here's what we're going to do. We are going to insert a graph here. And scatter plot. Not exactly what we wanted. I need to select my data first. Let's try this. That looks better. Okay, so here is, on the x-axis we've got temperature. On the y-axis we've got rentals. Okay, y, dependent variable, rentals, x, independent variable. We could be using temperature to predict rentals. And when we do that, okay, we see a couple of things here. What it would look like is that when it's cold, people don't like to rent bikes, which makes sense, and that's what we saw a little earlier. But on the high end, it gets a little more difficult to interpret because it does seem like as temperature increases, there's more bikes being sold, right? And we can actually see that if we add a trend line here. So a linear trend line, maybe see if I can change the color of this. Okay, so we've got our linear trend line here. in orange. And this is what we'd expect, right? The warmer it gets, the more people are running bikes. But if you just look at the blue dots, it does look like this could be kind of like a rainbow shaped or inverted U shape. And so we can statistically test to see if that is actually a better way to be looking at this data. So if we just change that to a squared version of this, now we see the trend line looks different. Okay, but we haven't statistically tested for that yet. We've only statistically tested for this straight line. But as you can see, we see that bend starting to take place. So maybe what we should be checking for, which is what we'll do in number 11, the last question, is it better if we look at this data as a curved line rather than a straight one? Okay, so let's go do that. I guess I'll show you number 11. Okay, nothing really to fill in here for number 10. Last question, number 11. Let's move that to a new page here. There we go. It's now number 16. Run one additional regression analysis to test if temperature's relationship to bike rentals is curvilinear. Okay, we think it might be based on that scatter plot we just looked at. But let's go back to the data and actually test this. Okay, and to do this, I'm going to copy my original data one more time. And there's instructions on why and how we're doing all this in your notes. Okay, I might rename this one data curve or something, curvilinear. And so in order to do this, all we have to do is add one more variable and take our temperature numbers and just square them. Okay, so I'll name it temp squared, and literally all I'm doing is I'm taking the original number and squaring it. Okay, I do that for all of them. And notice these numbers, they look crazy, right? Like some of them are over 1,000, 7,000, 8,000. They're kind of meaningless numbers by themselves, but behind the scenes, this regression, it's taking this and making meaningful conclusions based on the numbers. So this 2064, it's a meaningless number to us, but behind the scenes, the statistics, it knows what it's doing here. And so now we can set up that regression equation once more. Go back to data analysis. We're going to run one more regression, but this time we're going to use that squared term. Okay, our dependent variable is still rentals. So I'm going to select all of that data. This is a little tedious. Nonetheless, there we go. And then our X range, very important when you're working with this curvilinear regression, you need to select the squared term, but you also need to select the unsquared term. So I'm going to use temp squared, and my other two independent variables. Okay, and I'm going to take all the data from all four of those. And now I have everything I need to see if this data is better analyzed using curvilinear line rather than a straight or linear line. Okay, labels is selected, and we'll put that in a new worksheet ply. And so here's my new regression. Sorry, that's so small. Let's make that a bit bigger. Okay, and I might name this regression curved. Okay, and what I'm looking for to answer this last question, is it curvilinear? What I'm looking for is that squared term statistically significant? So I'm going back to the p-value of this new regression, okay, right here, and looking for my squared temperature independent variable. And sure enough, there it is. Okay, e to the negative 34th power, so 0.0000, 34 zeros, really, really small, close to zero, well under the threshold of 0.05 p-value. And so we can conclude here that yeah, temperature should be looked curvilinearly. So when it's 70 degrees, like in question 9, we're likely to rent a bunch of bikes. If it's 0 degrees, that's too cold for people. And if it's 120 degrees, well, that's too hot for people. So really, this is a bell curve, temperature as it relates to bike rentals, and people like somewhere in the middle. That's when you're going to sell or rent the most bikes. Okay, and so, you know, our answer here could be something like p-value for the squared term, oops, that needs an S, squared term is statistically significant, p less than 0.05, therefore, let's say, significant curvilinear relationship exists between temperature and bike rentals. Okay, so that would get you full credit for this assignment. And your assignment I've got posted in the course is similar to this. Certainly, if you have any questions on how to do this, let me know that, okay? You won't actually need Excel on the exam or on the homework. I'm going to be kind of giving you the outputs and asking you questions based on it. So in other words, I would give you this. I'm not going to have you do this on your own. I would give you this and I would ask you questions based on it. Like, you know, what does this r squared mean? What do these p-values mean? What does this minus sign mean here? Like for humidity, right? Those are the types of questions I might ask. Kind of a longer video this time. We're at 37 minutes now, so that's certainly enough for this. Again, let me know if you have any questions, and until next time.